Okay, so I'm going to go through one problem type for each problem on the test, and I'm just going to make one video, guys, because it's after school was canceled because it's snowing, and I'm still at school, and I've got to drive home safely. So I was planning on doing a separate video for each type, but I'm just going to go through fast and do one of each in the same video. So, okay, problems like number one. So you'll be asked to determine and explain the following things given the graph of f prime. So I will do the first one. All right, so let me just draw a picture of it so I don't. Alrighty. Like this. All right, so that's -4, -6, and 7. All right, so you really need to know Susan's table, okay, right here. And this is the graph of f prime. So you want to look in the f prime column, and then you're going to be able to say, because this about f prime, therefore this about f. Because this about f prime, therefore this about f. Because this about, you know what I'm saying? So first, where is the function increasing? Okay, so what about f prime would imply that f is increasing? So you look for f increasing, it would have to be this. So I'm looking for where f prime is positive, that's going to give me where f is increasing. So it's positive, okay, so f prime is positive on this interval. And then for the reason, because f prime is greater than 0. Guys, on the last test, a lot of people were like, because that's where it's greater than 0. You have to actually say, you have to be specific, because f prime is greater than 0. So B, decreasing. Decreasing is going to be where f prime is negative or less than 0. So negative infinity to -4 union 4 to 7. Now, I did this union, guys. If I will explain, all right, at a certain point, I think I will explain to you why the answer could also, you could also express it just as negative infinity to 7. But the reason why I'm expressing it like this is because the reason is because f prime is less than 0. And f prime is 0 at -4. So if I say from negative infinity to 7, then my explanation doesn't work for the point -4. Whoops. All right, so that's why I'm doing this union, because for f prime to be less than 0, it's only less than 0 on those intervals. Okay, and then C. Concave up. Okay, now again we're looking at the f prime graph. So we have to look for f concave up, and f is concave up when what about f prime? When f prime is increasing. So my explanation is going to go, you know, since f prime is increasing, f prime, or f is concave up. Since this, then that. If this, then that. So where is f prime increasing? It is increasing here, and then it's increasing again there. All right, so negative infinity to -4 union. Oh, shoot. Duh, that's 0. Union 0 to infinity, because f prime increasing. Don't say because the graph is increasing. Don't say because it's increasing. F prime. Okay, and then for concave down, it's going to be -4 to 0 because f prime is decreasing, A, B, C, D. And then E, okay, where does the original function have a local maximum? A maximum is an extrema. So I'm looking for a sign change. So the only point that I have a sign change at is this right here, because f prime is going from negative to positive. But going from negative to positive, f prime going from negative to positive means that f goes from, it means that f goes from decreasing to increasing. So that's not going to be a max, that's going to be a min. So there is no max. So I'll say none because f prime never changes from positive to negative. All right, so there's no max. E, F. Now they're talking about local mins, so X is 7 because F prime changes from negative to positive, and then points of inflection correspond to extrema on F, and we've got 2 of them. Okay, so there's 2 local extrema. So X is -4. Let me say them separately. X is -4, X is 0, because F prime has extrema at these X values. Notice all of my explanations, because F prime, because F prime, because F prime, because we're given the graph of F prime. Okay, problem type 2, it's gonna be, you'll be given F double prime. So let me, okay, so, all right, so number 2 is gonna be like this. And guys, it might be a good idea to, like, you know, not watch this video the whole way through. Maybe now is a good time to pause and try a problem type like number 1. All right, so here's like, all right, so this time this is F double prime, and right here, -8, -5, 4. All right, this is from the packet. Okay, I'm doing this one from the packet. So you'll be asked to determine and explain the following things given the graph of F double prime. So concave up intervals, concave down intervals, point of inflection, and we're going to explain. And because we're given the graph of F double prime, every explanation is going to be because F double prime blank, because F double prime blank. Okay, so first they're asking where is F concave up. So you look at F concave up, but we have the graph of F double prime, so you got to go over here to the F double prime column. So we're looking for where F double prime is positive. If F double prime is positive, then F is concave up. So part A, from -8 to 4, and then you say because F double prime is greater than 0. B, concave down, -infinity to -8 union 4 to infinity, because F double prime is less than 0. And then C, for point of inflection, I'm looking for a sign change. All right, so we've got sign changes at those values there. So X, it doesn't matter how the sign changes, it just matters that the sign changes. Like with an extrema, like the last one, you had to be specific about like negative to positive or something, but For point of inflection, just say sign change, because I'll say f double prime, I'll say experiences a sign change. Excuse my handwriting. What a long day. Okay. Now, problems like number 3 on the exam. Okay, so number 3, you're going to be asked to find the absolute max and min of a function on a closed interval. You'll need to show that you use the candidate's test to arrive at your answer. Here is what the candidate's test looks like. You put the endpoints of the interval here, and then in between here you put the critical numbers. All right, and remember from last unit, critical numbers are where no. Let me just say it. It's where f prime is 0 or undefined. All right, so let me just do number, I guess I'll just do, what do I do? Let me do 38. Okay, so I'll do 38. All right, so we've got f of x. All right, so this is number 3. All right, so here's a problem like number 3. You're going to have something like this. Okay. And I'll ask for the, what do I ask for? Absolute max and absolute min on that interval. Okay, so this is the candidate's test. Candidate's test. This is what you always do for absolute max or absolute min. All right, so you're going to put the first endpoint up here, and then the last endpoint. You don't have to do it in this order, but then you'll put the last endpoint, and then in between them, I'm just giving you a visual, in between them you put the critical numbers, which are where f prime is 0 or undefined. So I go f prime, all right, is -6 plus 2x. And then I set it equal to 0. So this is 2x minus 6 is 0. 2x is 6. X is 3. You only need to put the critical numbers here that fall within this interval. Like if one of my critical numbers was -10, then I wouldn't even put it into the candidate's test table because it's not within this interval. So I just put 3 in there. And then you plug these values not into the derivative but into the original function. All right, so if you plug 0 in, you get 1. If you plug 3 in, tell me this calculator works. It doesn't. Just a second. Okay, I plug 3 in. 1 minus 6 times 3 plus 3 squared. -8, and then 4. And then that's -7. And then you look for the highest y value, and that's the absolute max. You look for the lowest y value, that's the absolute min, but you've got to tell your reader where they occur at. So I say to you here, for absolute max, for absolute max, I could say absolute max is something at some x value, or you could state it like that. All right, so I guess I'll say it like, okay, so I'll say absolute max, I'll say it is 1 at x equals 0. Or you could say or you could say f of 0 is 1. All right. And then absolute min is 3. No, it's not. It's -8 at x equals 3. Okay. Now, so those are from last unit. Now we're on the stuff from this unit. So take a break, guys, or pause the video and try some of those. All right, so number 4. You will be asked to use properties of integrals to evaluate the integral expression, and I will ask you to use proper notation and to do it in no less than a specific amount of steps. So let me choose one that is kind of hard. Let me do 11. Okay, I'll do this. Okay, so this is what, all right, so this is going to be like number 4 on the test. So they are telling me that the integral from 1 to 3 of f is 5. Okay, this is not proper notation, all right? I'm just writing it down fast. And then 1 to 3, g is -2. I'm just copying what they're giving me over. F is 2, 3 to 5, g is 1. Okay. And I'm going to evaluate, given those things, I'm going to evaluate this, and I'm going to do it in no less than 4 steps. If I want to do more than 4 steps, that's fine, but no less than 4 steps. So I'm going to write this down. So 1 to 5, 2 f of x minus 3. Okay. Step 1, I'm going to split up this integral. So I'll number my steps. So here's step 1. The integral from 1 to 5 to f of x dx minus the integral from 1 to 5 3g of x dx. Okay, this is what I mean by proper notation. Okay, then I look at what I'm given. Guys, I don't have, if you look at the endpoints of what you're given, it's 1 to 3 and 3 to 5, not 1 to 5. So the next thing that I'm going to do is I'm going to express these integrals from 1 to 5 as a sum of 1 to 3 and 3 to 5. Okay? And I mean, if you think of it like this, okay, so you don't have to do this, but okay, so let's say that this is 1, 2, 3, 4, 5. Okay. You can see that, so we want 1 to 5, so we can add 1 to 3 plus 3 to 5. So I will express each integral, and I'll split it up like that. So this will be step 2. So this is the integral from 1 to 3, and you could do it in a different order. 2f of x plus the integral from 3 to 5 2f of x dx minus, oh, this is going to get kind of tricky because of that minus. Okay, because now I'm going to split this up into 2 things, and I'm going to be subtracting like both of them. So the integral from 1 to 3, and I don't think the one on the test is this long, plus the integral from 3 to 5. Okay, all right, so step 2. Now, guys, I know what the integral from 1 to 3 of f is. And I know what the integral from 3 to 5 of f is. And same for g. I know what the integral from 1 to 3 of g and what the integral from 3 to 5 of g is. But I've got these constants on the inside. And this is where I'm going to use the constant multiple rule and pull them out. So this is step 3. Okay, so I can pull out this constant multiple. So 2 times the integral from 1 to 3 of f of x dx plus 2 times the integral from 3 to 5 f of x dx minus 3 times the integral from 1 to 3 g of x plus 3 integral from 3 to 5. Okay. And now finally I can substitute in. All right, so this is the 4th step. So I'm just carrying down this 2. I'm carrying down that 2, but guys, what is that? They told me that it was 5. So it's going to be 2 and then, all right, let me go like this. All right, now this 2 comes down. I'm leaving a blank, minus. This 3 comes down. I'm leaving a blank for the integral, plus the 3 comes down. Okay, I'm just trying to provide a nice visual. Okay, so what is this? It's 5. What is this? It's 2. All right, how do I know these things? It's because that's what they gave me. What is, you probably get the point, but I'm just going to keep going with my visual. What is that? It's negative 2. What is that? It's 1. Okay, so I'm actually, so the direction said no less than 4 steps. I'm actually, so my 5th step is when I simplify. So this is just 10 plus 4 minus negative 6 is 17. Okay, and the one on the test is not that long, but that was a good one. That was hard. Like a lot of writing. Okay, so now number 5. Okay. Number 5, you will be given a definite integral and asked to write it as a limit of a left endpoint or a right endpoint Riemann sum. Okay, guys, you just have to know the formula. So I will do the first one. All right, so I'll do the first one for both. Okay, so number 1. Okay, so this is the integral from, and you do not have to show all the steps that I'm about to show. Okay, but, okay, so I guess what I would ask you to do is, okay, so I know, all right, so from negative 4 to 1, all right, well, first of all, let me say what delta x is. So delta x is 1 minus negative 4 over n. Okay. Alrighty, and then, you know, remember this sequence, you don't have to do this, but x sub 1 is negative 4. Well, x sub 0 is negative 4. X sub 1 is negative 4 plus one of those. x sub 2 is negative 4 plus 2 delta x. And this is only something you might want to do if you ever forget the formula. X sub k minus 1 is negative 4 plus k minus 1 times delta x. And then x sub k is negative 4 plus, all right, so just like we did in the video. All right, so for the left endpoint Riemann sum, I'm going to be plugging this in to my original function. And for the, so this is for the left one, and that's for the right one. Okay, so this is what I'm using. Okay, so if I ask you, I'm only going to ask you for one. Oh my gosh, I can't even write. If I ask you for the left one, it is going to be the limit as n approaches infinity, and then you do the summation from k equals 1 up to n of, okay, the height of the rectangle is given by plugging the left endpoint into the function. So I got to take the function, which is 4 blank, and then I plug the left endpoint into it. So negative 4 plus 5 k minus 1 over n. So this would be the height of the k minus 1th rectangle, but then I multiply it by the base of the rectangle, which is delta x, which is 5 over n. Okay, so that would be for the left one. And then for the right one, if I ask you for the right Riemann sum, it's the same exact thing, but instead of k minus 1, it's just k. So the limit as n approaches infinity, okay. And guys, if you, like anything that you, this video is optional. Anything, if I'm like boring you, like you know this, then obviously just move on to something you don't feel as confident with. Okie dokie. So that's the 5th one. Number 6. Okay. Number 6 is going to be like this. You will be told that a function is continuous, and you will be given a table of values for the function. You will be asked to use a trapezoidal sum to estimate the area under the curve. Okay, so I guess I'll just do the first one. So this is the definite integral that we're going to estimate, and it just means the area under the curve from negative 4 to 3 of that. So I'm going to plot these points, like do like a sketch. And some of you, if you could do it in your head without a sketch, that's fine, but sketch is nice. So 1, 2, 3, 4. 1, 2, 3. And then I want to go all the way up to 12, because that's my highest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Negative 4, 1 is the first point. 0, 1, 2, 3, 4, 5 is the next point. 2 all the way up to 12, and then 3, 1, 2, 3. Okay, 3, 6. And then, okay, so there's the points. But guys, this is the key word here. Continuous means that we can connect the dots to make the graph, okay? And you could connect them, you know, you could go like this and then that and then that, or you could go like this and then that and then that. You could even be like, whoop, you know, but you just got to connect the dots. And I'm going to connect them in like the simplest way possible. That makes sense to me. Okay, something like that. And now, for a trapezoidal sum, you know, you might ask yourself, well, how many subintervals? Guys, they're only going to tell you the amount of subintervals if they want you, you know, to use like an equal, you know, subintervals of equal length or something like that. But they're giving you these points because these are the subintervals they want you to use, from -4 to 0, from 0 to 2, from 2 to 3. So my first subinterval will be from -4 to 0. And I'm using a trapezoid. So I just go up to the function from both endpoints and then connect. So this is the first trapezoid. And remember, the trapezoids are on their side. So really, it's like when we go to do the area, it's going to be 1/2 base 1 plus base 2 times the height. Okay, the trapezoids are on their side. Okay, now the next interval is 0 to 2. And guys, I just want to say, if you're listening to this with sound, just because you understand when somebody else is doing something does not mean that you'll definitely be able to do it by yourself. So please make sure that you practice. All right, so that's the second trapezoid. Again, it's on its side. So when you do the area, it's going to be 1/2 base 1 plus base 2 times height. And then, so we're going to use 3 trapezoids because we've got 3. And trapezoids give you a pretty great approximation. Okay, so I'll say trapezoid 1 is 1/2. Okay, base 1 is this height. Base 2 is this height. So this is base 1, this is base 2. So 1 plus 5, and then the height of the trapezoid is this, which is 4 units times 4. Okay, because the trapezoid area is 1/2. All right, this is the formula that I'm using. Okay, second trapezoid, T2 is 1/2 5 plus 12 times, this is the height this time, is 2. Trapezoid 3 is 1/2. 12 plus 6, and this height is 1. Okay, and then I'm gonna like add those together. Okay, so this is 6 times 18. Okay. When I add them together, I get 38. So let me just state this real nicely for my reader. The integral from -4 to 3 of g of x is approximately 38 square units. Okay. So there will be a trapezoidal sum. I would need more paper. I'm just getting more paper. Okay. Oh, we're moving on. We're getting there. Now, the 7th one, you will need to find the average value of a function. So, Okay, so this is like number 7. And this one should take you like 2 seconds if you know how to do it. You will be given a function on a closed interval. You will be asked to write an integral expression for the average value of the function, and then you'll have to use your calculator to evaluate the expression. So I'll do number 63. Okay, I'll do this one, number 63, right here. Okay, so you need to know average value of f of x over some closed interval a, b is equal to 1 over b minus a. And guys, I have a beautiful proof for this that I'll show you later. And it's not even hard to understand at all. I'm excited. And then, okay, so you just need to know that formula. So the first part, so part A is going to be just expressing the average value as an integral expression. So it's going to be 1 over 4 minus 0 is 4 times the integral from 0 to 4 of 2x plus 1 dx. That's what it is, all right? And then for part B, you just need to evaluate it. So you're just going to use your calculator. In the future, we'll know how to do this without a calculator, but you just are going to go 1/4, yeah, or you can go alpha y equals 1/4 times, I don't even need that times, I think, and then math 9, okay, and then that pops up, 0 to 4, 2x plus 1, and then just type in x, boom, 5. Okay, so that is the average of all the y values of that function over that interval. So that this allows us to average an infinite number of y values. And again, I'll do the proof later, but right now we just have to know the formula. And number 8. Okay, problems like number 8. Okay, you will be told that a function is continuous, that's important, and you will be given a table of values for the function. You will be asked to use a left endpoint or a right endpoint Riemann sum to estimate the average value of the function. Okay, so the interval to find the average value over, I've got to give that to you, and I'm going to give you a table of values. All right, so I just need, okay, so the average value of g of x over -4 to 3 is equal to 1 over b minus a, so 3 minus -4 is 7, times the integral from -4 to 3 of g of x. Now this is why I'm going to have to tell you to use a left endpoint or a right endpoint Riemann sum to evaluate, because we need to, okay, so this here, we're going to have to get an approximation for, all right? So this is where you do the graph. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I should have written this out earlier, but that's -4, 0, 2, 3. Okay, 1, 2, 3, 4, 5, up to 12, and Okay, so I'll do left endpoint, sum. Okay, so here are the subintervals. All right, so left endpoint. So here is my first rectangle base. I'm using the left endpoint for the height. Okay, so there's the first rectangle. Second base, left endpoint. And then go like that. So there's this second rectangle. Oh, shoot, duh. What am I doing? Continuous. I basically just crossed that off. But continuous means, you know, that we can connect like that. Okay. And then the third one, base, height, completed. So it's not the best estimation, but it's okay. So rectangle 1. Rectangle 1, the height. Okay, so this is height 1, that's height 2, that's height 3, and then we're not even using that very last right endpoint for the height. So height 1 is 1 times the base is 4. Rectangle 2, the height is 5 times the base is 2. Rectangle 3, the height is 12 times the base is 1. And then you add those together and you get 4 plus 10 plus 12, we get 26. So the average value, I bring down that 1/7. Oh, shoot. All right, so I'm going to use an approximation sign because now I'm approximating. So this integral here is approximately, a very rough approximation of 26. So the average value is approximately 26 over 7, which is, yeah, 3.714, blah, blah, blah. So if you add up all of these infinitely, if we were to get the average of all these infinite y values, their average value would be about that, okay? And again, I'll prove that later. Okay. Almost done. Oh my gosh, I hope I survive the drive home. I'm sure I will. I'll go very slow. Okay, now, problems like 9 and 10. Okay, so right here. You will be given the first derivative of a function for number 9 and the second derivative of a function for number 10, and you'll have to use antiderivatives and the given function values to find the original function. Okay, so we'll do, okay, so number 9. I'll do this one right here. Okay, so you'll be given something like this. And you'll know like that. Okay, so you got to go backwards, antiderivative. So f of x equals, bring down the 3. What's the antiderivative of e to the x? Is just e to the x plus 1/2 x squared plus c. Okay, and then you have to use this condition here. All right, so f of 0 is equal to, this will just be 3 plus c. Then, so 3 plus c is equal to 4 because f of 0 is 4. And you can organize it differently than me. So c equals 1. Therefore, f of x is 3e to the x plus 1/2 x squared plus 1. All right, so this is the function. You take its derivative you end up with that, but also f of 0 is 4. So this is the function that satisfies these two conditions combined. Okay, now for number 10, you're going to be given a second derivative. Now, this book, like all of the conditions they're giving you, it's like f of 0, but it won't necessarily always be 0 that they're giving you as the input on the original or the first derivative in this case. So this time we've got f double prime is equal to 12x squared plus 2e to the x. And then we also know that f prime of 0 is 2. And then we also know that f of 0 is 3. Okay. So I've got to go backwards twice. So f prime of x equals, so this is going to be 12 over 3x to the third plus 2e to the x plus c. So f prime of x is 4x to the third plus 2e to the x plus c. Okay, and f prime of 0 is 2. Okay, so then f prime of 0 equals 2 plus c. So then you get 2 plus c equals 2. So c equals 0. Okay, so we know that f prime of x is 4x to the third plus 2e to the x. Now I've got to go backwards again. So so now f of x is equal to 4 over 4x to the fourth plus 2e to the x plus c. I'm going to use d because we already used c. So I'll use d plus d. You could use anything. Usually c is what they use. So this is f of x is x to the fourth plus 2e to the x plus d. And then we know that f of 0 is 3. So then you get f of 0 equals 2 plus d. So then you get 2 plus d is equal to 3. So then you get d is 1. Therefore, f of x is x to the fourth plus 2e to the x plus 1. Okay, guys, so that's it. I hope that that's helpful. Again, I'm sorry I had to just do it all in one chunk, but just practice, practice, practice. And I'll talk to you later. Bye-bye.